Okay, I just opened the Zoom. It's 5 o'clock. Oh, okay. Um, Next time I should disable that so it doesn't have the people I need to admit. Um, okay, so hopefully this recording works a little bit better than last time. I'm still working on the setup here. But let me just orient everything real quick. Get rid of extra windows. Let people trickle in. What I did was I saw the questions that people posted. So thank you all for doing that. And I'm just going to go through in order from bottom to top because that's the order that they were posted in. And there's only a couple repeats. So it's a lot of problems. I'm going to maybe go a bit like explain the process for them. And then if we have time at the end, I can go back and solve some in more details. People who are in the Zoom right now, can you give me like a thumbs up or a message in the chat that you can hear me okay? Oh, maybe people are getting reactions I won't see. Can I manually open the chat? Well, I'm going to stop share real quick so I can see the chat. Okay, all good, can hear. Sorry about that, everyone. Okay, so first question here from Benjamin was about a couple problems. The first one has been solved, so congratulations, Benjamin, on getting that one. And then the other about problems 2 and 14 from homework 2. So for homework 2, problem 2, Benjamin says, I'm solving for theta in terms of x and separately in terms of y. When I plug one into the other, this is still in only one term. So how do I get both of them in one equation? So it's this 2 sine theta to cosine theta problem right here. And so what we've got is, oh, let me write it and then I'll switch. X equals 2 sine theta, y equals 2 cosine theta. We're told 0 is less than or equal to theta is less than or equal to 2 pi, and we're trying to get f of xy equal to 1 by eliminating the theta. And so a lot of people went about this sort of going, if x is 2 sine theta, then theta must be, like I divide by the 2 and I take sine inverse. And doing the same with the y and kind of trying to set them equal and then undo the equations. But you run into problems with the inverse sign here. And so what's actually going to help us out here is to recognize that we have a function that depends on sine and a function that depends on cosine. And we remember that there are some special trig properties. Sine squared theta plus cosine squared theta is equal to 1. So if I have a sine squared and a cosine squared, my thetas go away and I get something equal to 1. And so if you combine this with x is equal to 2 sine theta, so x squared is equal to 4 sine squared theta, and do similar for y, you can take x squared plus y squared, figure out what that would be equal to, and use your trig identities. To cancel out the thetas using this trig identity. So I'm just going to do a real quick like breeze through describing all the problems for people who came into the room a little bit late, and then I can go back and go into more detail on requested problems or just in the order they came. So I'm going to advance to Benjamin's second problem, which was I'm taking the equation for a sphere and completing the square to find my center points and radii, but my answers are still wrong. Am I taking the wrong approach to solve this? And it's for problem 14 on the second homework, where you've got all these pictures of spheres and you're trying to match them to the equations. And so the advice I would give here, can I make this any bigger for you all? Sorry, I struggle a lot with the Zoom share screen menu blocking my toolbar. Okay, that made the pictures a little bit bigger. So Benjamin talked about completing the square on some of these, which you do have to do. But before you even jump into that, I would kind of match the ones that you already know the form of. So for example, on x minus 1 squared plus y minus 1 squared plus z squared equal 1. This one right here, number 2 I'm talking about, has that form. And so I remember that I can read the center off the x, y, z terms, where this z squared is just the z minus 0 squared. If you kind of tried to factor this out, hopefully you're convinced that that would give you z squared plus 0z plus 0. So it's just that z squared we saw before. And it was equal to 1. So my center comes from those 3 points, my 1, 1, 0. And my radius comes from the right-hand side, 1 squared. And so I would do kind of like process of elimination, like first identify that sphere on here. And the same with problem 4 and 3. Again, 3 uses that same idea that if I see just an x squared, that's x minus 0 squared. And so then, yes, this last one is the only one where you have to complete the square. You only have to complete the square in the x component, and it's going to go just like your homework problem from the first homework that was completing the square. And Benjamin mentioned taking that approach already. That is the right approach. It could be that the algebra is going wrong. One issue that I saw a lot of for this one in the first homework when I was walking around the classroom is if you all have this equation and you're trying to complete this square, I know that I need it to be x minus 2 because that would give me x squared minus 4x to cancel out the first two parts, and then there's an extra plus 4 there. So I have to subtract 4 here. And then if you remember that part, an error that I saw sometimes was that people would subtract 4 over here to cancel it out, but you have to add the 4 to cancel out what's on the left side. So if you've done the completing the square, maybe make sure that that last bit of algebra worked out so that you got the correct radius at the end. Okay, so I'm gonna actually find the chat again to see if anybody's posted questions about what we've done so far. Gotta stop the share to get that open. I'm just not seeing any questions, so I'll go ahead and continue. All right, so on to the next chronological order questions. Kyler posted about having questions about 11 and 12 on homework 2 from 9.5 and 9.7, and Killen also posted the same request a little bit later. So I won't answer Killen's question later because we're about to do that one right now. Killen says that they have the formula but might be implementing it the wrong way. And Kyler says just having trouble with these questions. So 11 and 12 are from that new section about lines and planes. So problem 11 is a plane intersection problem, and right now I'm just copying down the equations. And then there's a hint here. The intersection should be perpendicular to the normal vectors of both planes. We're trying to find a vector parallel to the line of intersection of the two planes. And this is one that a lot of people had questions about in class. And I think it helps to kind of have a picture, although it's a little hard for me to draw. But so let's say that this is two planes that are intersecting each other. Maybe that one's the first plane, and then that one's the second plane. And this right here is their line of intersection, where the two planes touch. And that hint is telling us that this line of intersection has to be perpendicular to the normal vector from the first plane, because that line of intersection lies in this plane, and the normal vector is perpendicular to everything that lies in the plane, so it must be perpendicular to that line. And same reasoning, the line of intersection lies in the bottom plane, so the normal vector for that plane is going to be perpendicular to that line, because it's perpendicular to everything that lies in the plane. So the line of intersection is perpendicular to both normal vectors. And then I can read the normal vectors off my plane equations. If I distribute this minus sign, I've got minus 3x minus 5y minus 5z is equal to minus 3. And for the second one, I don't have to distribute anything. So for the first plane, my normal vector is going to be minus 3, minus 5, minus 5. And for my second plane, I see a minus 2 connected to the x, and I see a 4 connected to the z, and I don't have a y. So this is another case where we kind of have to, similar to here where I didn't see anything connected to the z, so I knew it was a 0. I don't see a y here. That's the same as having 0 times y. And unfortunately, I've lost what it was equal to. And so that center entry is 0. And so that might have tripped people up. And then to finish this problem out, because we just want to find a vector that's going to go in the same direction as this line of intersection we've drawn, we have to remember from the first homework we learned this property of cross products, which is that if you take the cross product of two vectors, the direction of the cross product is perpendicular to the two vectors that made the cross product. So cross product n1 cross n2 will be perpendicular or normal or orthogonal to the two vectors that made it, n1 and n2. So through the reasoning that this line of intersection has to be perpendicular to both normal vectors, and this fact that we can take their cross product to find something that's going to be perpendicular to them, we know that our answer is going to be the cross product. So we're going to take n1 cross n2 to get that direction we're looking for. And then this trips some people up, just that it says non-zero. That's just because the 0 vector is going to be like perpendicular to everything. So it's kind of like a cheat answer if somebody doesn't specify that you need a non-zero vector. You may have seen that on a few problems so far. This one is asking us to find the distance of the point from the line. And I did not commit that to memory. So we're going to roll back here after I pull up, I guess just the video. This is the part in class where I'd ask you all to show me your notes so I can see the formula. So since I couldn't remember the formula, I went back to my YouTube videos, or you could just go back through your notes, and I went to the video that's called 9.6 distance formulas, and I have to watch an ad. That's not a choice that I made, just so you all know. It's a choice that YouTube made. Mine is about BarkBox. Okay, and then I'm just going to scroll to the end so I can see the distance formula finished out so I can write it down. So this is asking us to find the distance of a point to a line. So I would go back through my notes, and what can be confusing on this one is that there were two different distance formulas we learned, between a point and a plane and between a point and a line. And so we're looking for the second one in your notes. That was given as distance from point P to line with direction V and point Q. And that formula is that distance is equal to the magnitude of V cross PQ divided by the magnitude of V. And so for our, oh man, I saw while I was writing, I missed somebody coming into the waiting room. There we go. Got it. Okay. So then coming back here, we're given the point is 3, 5, minus 5, and the line is r equal to minus 1, 3t. Oops. Minus 1 plus 3t. 1 plus 3t, 5 minus 3t. And so kind of just matching everything to the parts of the formula, the point P is going to be the point we're given, so that's not too bad. The line with direction V and point Q, we do have to go back to how lines are set up. We know that the parts that aren't connected to T are the point. So my point Q is going to be that minus 1, 1, 5. And the direction is the part that's connected to T. So that direction V is going to be 3, 3, minus 3. So this formula depends on V, P, and Q. And now I've identified what V, P, and Q are. I need the vector PQ. But we learned how to do that in the first homework. We just subtract the first point entries from the second. So I do like minus 1, minus 3, 1 minus 5, 5 minus 5. This is still tripping some people up. Make sure that when you do this, you get 10 because that minus 5 becomes a positive. So I get like minus 4, minus 5, 10, I'm pretty sure. And then we would have to take V cross PQ, which I definitely don't have time to do, but we would just follow our formula or use that determinant approach if that's what works best for us. And then this magnitude thing, sometimes people take, like if I have minus 2, 1, 3, they say that this is like an absolute value, and they change it to 2, 1, 3. But that's not correct. Remember that this magnitude symbol means something that looks kind of like a distance. The magnitude is going to be that square root of V1 squared plus V2 squared plus V3 squared. So for example, for my V right here, that's going to be square root 3 squared plus 3 squared plus minus 3 squared. So just like square root of 9 3 times. And you would do the same for V cross PQ. So if you have the correct formula here, you didn't mix it up with the first formula that we learned, which is for a point to a plane, then make sure that your algebra isn't messing you up anywhere and that you're not using the wrong type of magnitude. And then also be real careful with that cross product. We've still got a lot of people having mistakes with that because there's just so much arithmetic to do in that cross product. So if you know you have the right approach, check those 3 places where common errors occur. Next up, David posted asking questions about problem 8 and 10. I'm just closing some tabs so I can actually see the webwork tab that I opened. Problem 8 and 10, again on that homework too. So problem 8 is find a non-zero vector normal to the plane. So I'm going to go ahead and write that. So we're just being directed to find a normal vector. It has that like trying to trick you up a little bit or just trying to cover its bases specification that it has to be non-zero. But we know that the formula of a plane is like this. 0 equal to a times x minus x0 plus b times y minus y0 plus c times z minus z0, where n equal to a, b, c is the normal vector. And x0, y0, z0 is points, but that doesn't come up in this problem. So in this case, all we have to do is rearrange this whole thing we're given to just 0 equals your x terms plus your y terms plus your z terms. Right here you see they're kind of on opposite sides, so you need to move that y term over. And then we're just going to read off a, b, and c in front of x, y, and z. And then that's going to give us the direction of the normal vector. And if you were trying to do it this way and it wasn't accepting it, maybe try the vector notation, which we found in class webwork is a little bit happier about sometimes. If you think you're doing the right thing but it's still coming out wrong, maybe just make sure that like no sign swap issues happened. You see this like 2 times 5 minus y would be kind of tricky because I might like subtract my 2 times 5, here. So I might subtract it to the other side, so the y is with the x and the z, but my c and b and a are given times the positive y, so I would have to like distribute that minus 2 times that minus y. This would actually be a positive 2 times the y. And so if you did that algebra and you got minus 2, because you see the minus 2 out front, just make sure to check that all your signs have kind of canceled out. So again, be careful of arithmetic. Oh no, don't know what that is. I promise I'm pressing the cancel button. Yes. Okay. And then, oh, I did want to check real quick if anybody posted last minute. Nope. Okay, and then next up was the request. It was 8 and 10. So there's, oh, I can move it. Great. There's, I know, I'm sorry. There's 10. So 10 is asking us, it says an implicit equation for the plane passing through the point 252 that is perpendicular to the line is blank. So I'll admit this is said in kind of a clunky way. It's asking for an implicit equation for a plane, and they tell you that it passes through this point and it's perpendicular to this line. So kind of same idea. Plane plane equation is 0 equal to a times x minus x0 plus b times y minus y0 plus c times z minus c0. For normal vector a, b, c. Sorry, I forgot to switch over to this. And point in plane x0, y0, z0. So let's see what we're given here. We're given that the plane should pass through this point 2, 5, 2. So that part's pretty easy. I would just replace that with x0, y0, z0. We're also given, real quick, I'm going to copy down this perpendicular to the line, 3t minus 5, 5 plus 2t, 5 plus t. Perpendicular means normal, so it should be normal to this line. And so there's a couple different pieces to this. If it's perpendicular to this line, that means the normal vector is the direction of the line. And then we just need to read off direction of the line, which we talked about earlier is the stuff attached to the t's. So like my A, B, C are coming from the numbers multiplied by the t's. This one's a little tricky. I don't see a number in front of it. That's because it's a hidden 1. 1 times t is just t. So it's kind of like that z minus 0 that we saw before, but 0 means nothing in addition and 1 means nothing in multiplication. And then you would just take the direction that you find there and combine it with the point that we're given into this plane equation. And then you should be good. Implicit throws some people off here. It just means that you don't explicitly solve for the variables. So explicit, not explicity. Is like y equals 3x or z equals x plus y. Implicit is like y minus 3x equals 0 or z minus x minus y equals 0. Kind of like that f of xy equal 1 problem we started with. That's an implicit equation because you don't solve for y in terms of x. Yeah. And then last is Garrison asks on the first homework, what is problem 18 asking for? And problem 18 is that weird cross product problem. And so I talked about this a little bit in the first problem solving session videos, I think, but just in case, I'm gonna say I hat, j hat, and k hat you need to know are our coordinate vectors. So I hat is 1, 0, 0, j hat is 0, 1, 0, and k hat is 0, 0, 1. All of those are our coordinate vectors. That means that if I draw my xyz plane, they run with the coordinate axes. So I hat goes 1 in the direction x, j hat goes 1 in the direction y, and k hat goes 1 in the direction z. So once you know that, the problem says, use the geometric definition of cross product and the properties of the cross product to make the following calculations. So it's asking you to do something fancy, use geometry and cross product properties to get these answers. But as far as just getting answers to a problem, you could go ahead and with what I've given you, calculate I plus j must be 1, 0, 0 plus 0, 1, 0, so that's 1, 1, 0. And then take a cross product, use your messy formula or messy determinant, whichever one you like more, and then get a number out of it. So, like, if all else fails, brute force this problem. Just take your cross products the way that you know how to take cross products, and take your vector additions the way that you know how to take vector additions. But if you wanted to do it the fancy way, which is a little bit easier, we need to remember a few properties. So the first one is that the cross product is perpendicular to the original vectors. And cross product of parallel vectors is 0. You can figure that out from like the sign definition of the cross product, or thinking about the fact that it describes kind of the area of a parallelogram formed by two vectors. If those vectors are parallel to each other, then you can't form any space between them. So of course you would not get anything out of the cross product. And then the cross product distributes like multiplication. But order matters. So by order matters, I mean that I hat cross j hat is not the same as j hat cross I hat. They're actually negatives of each other. And so if we want to do one of these problems kind of this more clever way, let's do the first one, I hat plus j hat cross I hat cross j hat. It's really hard for me to visualize what I hat plus j hat is and what like a cross product is. And so the first thing I'm going to do is go ahead and distribute some things. So this is going to be the same as I hat cross I hat plus j hat cross I hat. And then all that's going to be cross j hat. And I'll distribute that one a little bit later. So all I did was I took the I hat and I multiplied it through. And then to get these cross products, I can go ahead and use the other two cross product properties. So I hat is parallel to itself, two vectors that are the same, run in the same direction. So this I hat cross I hat I know has to be 0. And then this j hat cross I hat, we have to kind of go back to the coordinate vectors and realize that, sorry, I keep hitting go back instead of undo. Realize that if I have this property that cross product is orthogonal to the original vectors, then if I take cross products on these coordinate vectors, kind of I'm always going to end up with another coordinate vector. So if I took I hat cross j hat, I need something that's perpendicular to I hat and perpendicular to j hat, but I can see on this picture right here, that's definitely just k hat. Did it again. Did something different. And the order matters here. All the cross products are going to follow right-hand rules. So kind of if you go in the direction of the axes reading x, y, z, sort of the same way you would, you get positives. But then if you go opposite the direction you normally read them, you get these negatives like I talked about here. And admittedly, that's not something you would really know. A lot of people know it from physics classes. Is when you might have been exposed to it, but we don't I don't think, talk about that in earlier math classes. So anyhow, I hat cross j hat would be k hat, but I need j hat cross I hat, so that's going to be minus k hat. And then I can go ahead and do my distribution again. J hat cross 0, that doesn't matter, that's a 0. And so I'm just left with minus k hat cross j hat. And I can pull that minus out front so I don't have to think about it for now. And I could do the exact same reasoning of k hat cross j hat is going to have to go in direction I hat, or minus I hat. And the positive direction would be following the coordinate axes, so this is going to give me the minus I hat, and then those two minuses are going to cancel out to become a plus. So that's how you do these ones. If you have intuition for those directions, usually you can do all this kind of in your head. But if you don't, you should write it out carefully like this, or if this just makes no sense to you, there's absolutely no shame in just calculating the vectors. And talking to me later if you want to kind of figure out a way to remember what's going on here. Okay, so that was super speedy through the questions that I saw. Real quick, I'm going to stop the share so that I can check in the chat. There were people in the chat I saw earlier, but now I cannot open it because my Zoom is weird. There it goes. So does anyone who's joining online have questions right now? I know that was really lightning fast through everything. I just wanted to make sure that we would get through all the questions and I would have time to talk to you all in the chat. Yes, so I'm currently running my screen recorder, I really hope. Yes, I am running it. And so afterwards I'm going to save the recording and upload it, and it takes like 15 minutes for it to be processed by YouTube, and then it'll be available. Thanks for asking that. I'm sure Plate is like a way that your first and last name are put together by Texas Tech, but thank you, Plate. Are there other questions? If there aren't other, can you show how to read the graphs on 14? I sure can. Oh, gotta log back in. Problem 14. Is this on homework 2, just to confirm? Yeah? Okay, cool. So I'm gonna turn back on, can I pull this chat out? No. I will learn how to make my Zoom better before we do this again next time. Just for a little bit, I won't see you all in the chat again. I'm turning back on screen share, and I'm pulling up problem 14. So somebody asked in the chat, how do we read these graphs? I'm not really sure what I'm doing wrong. And it's definitely hard to read these 3D graphs, so I get it. So for example, taking this first one, A, the first difficult part is kind of orienting yourself. So your x-axis is right here, your y-axis is right here, and your z-axis is right here. And these are spheres, so the two things I need to know are where is the origin, what is the radius. And with that information, I could specify the whole sphere. So where's that thing? So in this case, my sphere, the center is this little dot that they draw inside the translucent shell. They indicate it with a colored dot. And so for this one, the center is at 0, 0, 0. And then to read the radius, I just go from the center, and it's usually easiest to go like in a straight line in a coordinate direction. So since this one is centered in all three coordinates. I can go any direction. I'll go Y because it's the easiest to read direction. So from the center to the edge, it takes me out to 2. Oops. So I can see that the edge of A is at 2. I'm even going to be clear, that's at Y equals 2. And if I started from Y equals 0, that means that I had a radius or distance between those two locations of 2. And then just one tricky thing is to remember that the radius is squared in your sphere equation. So this one would look like x squared plus y squared plus z squared is equal to 2 squared. And I hope that's a possible answer here, or else I'll feel kind of foolish. Yep, 2 squared is 4. So I know that A belongs to 3. Oops, I wrote that right there. Reading one that's a little bit more tricky, for example, B, it's kind of off center now. Let me do this so that we can see it and the thing I'm writing on. So for B, my center is at, here's my X, here's my Y, here's my Z. So it looks like my center is along X, it goes out to 1. Along Y, it also goes out to 1. And then I'm going to guess that that's at Z equals 0. It's a little hard to tell. In a second, I'll show you how to open that picture a little bit bigger. But on B, first go, I'm going to say that 1, 1, and 0 in Z is the center. And then to find the radius, I'm going to again think about it in the Y direction because that is kind of like the most similar to reading side to side on a piece of paper. So the edge of B happens right here. It touches the x-axis. So it happens at y equals 0. The x-axis is like here's 0 and y. Right there seems to be the edge of my sphere. And coming from the center at y equals 1, covered a distance or radius. Sorry, I ran off the screen again. That radius was 1. And so if I was going to write this equation, my first guess would be that this is x minus 1 squared plus y minus 1 squared plus z squared is equal to 1 squared. And I see that actually I don't have to rearrange anything, is right there. So I would say I think B goes to 2. And you would continue like that for everything. You should be able to also, if you're having trouble like figuring out exactly where something is in your picture, try right-clicking on the picture and opening it in a new tab, and then it'll like zoom it in better so that you can try to focus on where the points are sitting. So now we will wait and see if, oh, there's a key I can press. Alt-H, that worked. Okay, so hopefully that answered your question, Plate. Does anyone else have a question, or could I get some like all goods from the chat if there are no questions? I'm gonna wait because I know it takes some time for you all to like type up, find the chat box and all that. Right, I got an all good, and Garrison and Plate were the two who responded earlier, so it might be that other people just aren't very chatty. I did warn you all that this is going to be recorded, so you might not want to type in the chat because then people will see it. Tyler says all good. Great.